हेलो नमस्कार सर।
हाँ नमस्ते
नमस्ते।
नमस्ते
Am I audible sir?
Yes,
कैसे हो?
yes.
बढ़िया।
हाँ जी सर।
Yeah, you are audible.
Yes. Thank you so much, sir. Narendra
Thank
Kumar,
you.
sir. Yeah.
Thank you Santosh sir. Thank you.
Yeah. Nirvan, sir,
Yes, sir.
you can now start.
Okay, sir. Good evening, everyone. I hope you all are enjoying this intellectual stimulating journey at the AICTE sponsored ATAL Faculty Development Program. As we continue to delve into groundbreaking advancement into technology, we now arrive at technical session 4. The topic for this session is direct parade printing by 3D printing. Takes us a step further into the vast potential of 3D printing. It's showcasing its application into innovative manufacturing technique that promises to redefine how products are designed and fabricated. To lead us in exploring this fascinating topic, we were honored to have Dr. Narendra Kumar, faculty of Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. Dr. Narendra Kumar has received many awards and recognition. He has received Institute of India's Young Engineers Award in year 2021, Best Teacher Award by NIT Jalandhar in 2024. Sir has completed his mechanical engineering from Technical University, Uttar Pradesh, and dual degree MTech plus PhD in additive manufacturing from Indian Institute of Information Technology, Design and Manufacturing, Jabalpur in 2019. Dr. Narendra Kumar have a vast experience over 12 years in teaching experience with research at UG and PG level. He has secured 100 lakhs, around 1 crore research funding from ISRO, Bureau Investigation of Standard, and Scientific Engineering Research Board, SIR. His research expertise is in CAD/CAM integration, rapid prototyping, and tooling with additive manufacturing. He has also research expertise in material development and characterization in manufacturing. He has published around 50 plus research papers in international and national journals with peer-reviewed journals and conferences. He is also the resource person, invited speaker, and chair in various national and international conferences. Also in FDPs, HTTPs at reputed IIT, NIT, IIIT, government institute, and private institutions. Let's put our hand together to warm welcome him. Over to you, sir.
For inviting
Shading
me.
rights.
Yeah.
Hello.
Yeah, your voice is coming.
Yes sir. Yes sir.
No.
So first of all, sir, I am thankful to you for inviting me for this session and give me a chance to interact with the participants. So sir, now I'm going to share my screen. So please allow me.
Okay.
So I hope my slides are visible to all of you.
Sir, your screen is
No.
now shared. You just have to open your presentation.
No, I have opened my presentation. That's why, sir, I'm saying
No,
that.
yeah. Now your presentation is coming up. You just make it a slideshow. Yeah, it is done, sir.
Okay,
Yeah.
thank you, sir.
Yeah. Come. So it is second slide. Come to the previous slide. Yeah.
Yes.
Yeah, it is
Oh,
being seen.
now is it fine, sir?
Yeah. Yes,
Yeah,
yes.
yeah.
Yes, sir.
Okay.
Okay, so let me close this. I don't know what is. Okay. So
Yeah,
I
now it
hope
is
my slides are visible, right?
right.
Yeah.
Okay, so the topic of today session is the direct parade printing, where I'm going to means cover the scope, challenges, and I have case studies related to this topic. So so these three session. So first of all, I will talk about the challenges with the and then what is the necessity of that, what is this purpose, and then so now we need to first. So in short, it is known as process. Because here we use filament.
Your voice is not clear, sir. Your voice is, like.
Sir? But
voice is not coming clear. It's
okay,
kind of vibrate.
Hello.
Yeah, now it's okay.
Okay, so let me change the position of my mic.
Yeah.
Hello.
Now it's okay. Yeah, it's coming clear.
Okay, so thank you. Okay, so what is triple F? Triple F basically you all know, because I think previously you have gone through the 3D printing sessions where I think Pius or some other expert have covered the working principle of triple F process. So in this process, what we do, we use the material in the filament form, so that you can see here. So from the top, we are feeding material in the form of filament. So this is filament, right? And here we push this material, filament material, in the liquefier head of triple F. So with the help of these two rollers, we feed the material inside. So here is filament itself acts as a piston. Right? So if the properties are not as per the suppose the material is able to take the sufficient force that is required for heating, that is
Again, some voice issue. Voice issue is there, sir.
okay. So here, what are the challenges in the development process? First of all, material, you want to know, first of all, you have to form the filament of that material, or we can say that you have to prepare the filament of that material. Then only you can use triple F, right? So this is the first challenge that is very difficult, because sometimes we face a lot of difficulties in the formation of filament. And then second is the, due to this property, or this need, requirements for material with specific mechanical properties are required. Because as I told you that in this previous slide, filament itself act as a plunger, right? So if the mechanical properties are not as per the requirement to be act as a plunger, in that case you may face some of the problems with the triple F process, right? So what happens when we suppose, let us take an example of elastomeric material. We all know flexible materials have very low column strength, right? So when we push them against a small opening, in that case they can bend. This first case, right? So in this case, to look at the first case, here we are feeding the material, material in the filament. But in the second case, when we try to fill the material, this kind of situation, right? The opening of the barrel. Obviously, you this machine, the printing will fit, obviously we are not able to make the object of that material. So this is also one. So printing of the flexible material is very difficult. Of the insufficient force, pushing force, right? That is required to push the viscous melt against the nozzle opening. So here I have mentioned the challenges. So now, what are the solution? Because if you look at the library, material library of FFF, you will find the only limited materials in the library like EVS, PLA. Nowadays, PMMA is also available. PETG is coming, but still there are various polymer materials available in the market, but still only few can be printed through AAA process. As the reasons we have discussed already in the previous slide. So how can we overcome these challenges in 3D printing? So what we can do, we can go for the direct pellet printing, right? So instead of making filament of the material, or instead of forming the filament, what we can do, we can directly fed the material in the pellet form, right? So nowadays, if you search the keyword direct pellet printing, or just type pellet extruder, you will find the various websites, or you will find the various companies who are making nowadays the direct pellet 3D printing systems for the use. Okay, although they are costly if we compare with the triple F, but soon I think in future they will be comparable with the triple F also. Okay, so direct pellet printing is one of the solution of the previous challenges that we have discussed. So in triple F, sorry, in direct pellet printing (DPP), you can use the some mechanism that can the help us to extrude the material in the pellet form. Now the question is, what are the advantages, right? If we adopt this particular approach for 3D printing, what advantages we can get from it? So first is the reduced melt solidification steps. So as we are not forming the filament, obviously we are reducing the number of steps required for the material processing, right? And second thing is the elimination of filament extruder system. So obviously we are not using material in the filament form, so we can eliminate this requirement, because this is also very uh, tedious task to form filament, because in the triple F 1.75 mm means diameter filament is required. So this will be eliminated from the picture. And then support direct recycling of waste. Suppose you are planning to recycle the material. Okay, if suppose you are having a polymer that you want to recycle, or you want to use it with the help of 3D printing, you want to convert that material into a usable product. So in that case, you can directly cut that polymer into the small pieces, and you can directly feed that material through the direct pellet printing system, and you can convert that waste into the usable product. So circular economy is, I think, one of the that is very popular. So that can be through this. Okay, reduction in the cost of material. And we are using step. So obviously the requirement will be less. Okay, we are eliminating the use of filament export system. And we are also supporting direct recycling of this. So obviously it will lead to the reduction in the cost of the material. So this is also one of the advantages. Then next is increase in the number of types of polymer that can be recycled. So as I told you that is having library that is very small. So here with the pellets we can increase the number of types of the polymer that can be used through the system, or that can be recycled through the system. So that is also one of the advantages offered by the direct pellet printing systems, right? So obviously you can reduce the time, because we are not making the filament. So you can save the time, you can reduce the the uh, lead time also, right? So here I have taken this table from one of the research paper. So where they have compared the the direct pellet extruders and filament extruders for by taking some criteria like cost of the extruders, cost of the raw material, flow rate, quality of surface finish, variety of material that can be used, temperature of the extruder, printing of complex designs, reinforcement with fiber, cost of the final product. So if you look at some of the parameters, filament extruders are good. However, on the other hand, if you look at the parameters like output of the output user or variety of that can be used or extruder, in these areas, the extruders are better. Okay. So suppose you are planning to create the parts with inlet, you can go with, but you have to compromise. If you see the parameter of surface in this too, because of the bigger size vessels, right? And still the parameters of screw this identity system is not as fully. And triple F is well established process nowadays. So that's why you can see that difference in the surface finish of the printed parts, right? So this is one of the feature of this. But sooner, I think it will also be improved when more work studies or more case studies or more research will be carried out in this area. But here, if you compare the cost of the final product, it is low, right? So, and if I compare it with the triple F, it is very high as compared to this. So you can based on your requirement, based on your judgment, you can select the types of extruder head or type of printing system for your application. And one more thing I also discuss with you, that this formation of filament, right, challenge with the triple F. So suppose as a researcher or as a PhD scholar or MTech scholar, suppose my objective is to develop a polymer composite for 3D printing, right? So what I need to do in the case of triple F, first to matrix with the reinforcement material, and then I will convert that compounded material. So with triple F, we can simplify the polymer preparation. So here I have two images, like separate first is calling and there is reinforcement particle, and we do compounding, then we go for of that material to convert it into the filament form. Then we do printing, 3D printing, then we right. So here this is done at two stages. Filament property, because I have already covered that filament is needs the specific mechanical property, because it acts as a plunger in the case of triple F. So we need to check its property, whether it can be act as a piston or not. Okay, whether it can be used for printing purpose or not. If it cannot be used, then obviously we cannot go forward toward the 3D printing, right? But in the case of this direct pellet printing, only after compounding directly we can go for 3D printing. So also depending on the type of the processing method, compounding and 3D printing both can be done in situ, and it can be done within the barrel, compounding and 3D printing, and then we can go for the analysis. So obviously if you count the number of stages, so 1 2 3, so this filament or this extrusion process has been eliminated from the picture, and you can see it has simplified the polymer composite preparation through direct pellet printing, right? So now here now the question is how to process the pellet pellets of polymer. So here I mentioned two possible methods. One is the plunger based method. Second is the screw based method, right? So in the plunger based method, here what we take a cylinder, right? And then we take a plunger and we just fill all the pellets inside the cylinder, and just we increase the temperature with the help of heaters. So these are the heaters, right? These are the heaters, and with the help of these heaters, we increase the temperature of these pellets, and then we converted them into the viscous melt, right? And then slowly we move this plunger toward the downward direction, and then material comes out from this nozzle. However, in the case of screw based mechanism, we directly fed pellets from the top, right? And here we have this hopper. Okay, so we fill this hopper with the pellets, and then slowly these pellets goes inside the barrel, and this screw rotates either in the anti-clock direction or clock direction, depends on its profile, and then it create pressure, differential pressure here, and then material comes out from the nozzle on the platform, right? So now which one is having more benefits? If I ask you which one is good for 3D printing, then what will be your answer? Anyone, can you answer my question? If I ask you to choose any one of these method, which one you will opt on and why?
Sir, actually, all the participants are mute,
Oh, no issue, sir, no
and
issue.
they are giving their consent into the chat box. But I think your slide is visible. That's why you won't see the chat box.
No issue, sir, no issue. It's okay.
Now,
Later I will discuss with the participants. Right?
now I see one of the participants, Praveen Dhanore sir, said screw base.
Okay, okay. And what is the reason?
No, maximum participant giving the answer as screw base.
Okay, okay, good. Okay, good. I think, thank you.
Okay, please continue, sir.
So here, I think answer is correct. I will be mentioning the reasons here. Although planetary systems are simple to operate, right? But one is the major problem with these systems are this extrusion of the material, discontinuous extrusion of the material, because it makes it effective for fabricating the large object. Okay? Suppose the volume of the part is greater than the volume of cylinder, so obviously we need to refill the plunger again and cylinder again and again in the case of plunger based systems. But however, if I talk about the screw one, here we can feed material continuously because the screw is rotating and we are feeding material from the top. So here we have a provision to feed material continuously into the hopper, and we can make some provision on the top. We can add some of the storage tank, or we can provide some mechanism pipe through which we can directly feed material uh, into the hopper. It is like a floor mill, okay. And one more thing is the screw also allow a more precise control of the extrusion process. Okay, it homogenize the molten material or the viscous melt, right? And also it allow the some level of mixing. You are planning to make the composite, then you can feed two materials directly into the hopper, so it can mix the both the materials at some level. So this is also one of the advantage with this. So due to this screw based mechanism or screw method means maybe used uh, to process the pellets in the direct pellet printing systems, right? So based on this, I have few case studies get to this direct pellet printing. So in my all cases, I took this screw based mechanism, right, to process the material. So here the first case study is the in-house development of direct parity printing enabled EM system, right? So here you can see that during my doctorate, I developed this setup where I mounted that tool, or you can say that I developed a tool that was mounted on the CNC machining center. So in general, CNC machining centers are used to machine the parts or machine the component. So basically, their use is to remove the material from the stock in the form of chips. But I used their setup for the uh, for the extrusion purpose. So I made this particular method. I devised this method and I mounted this tool on the CNC machine center, and then a lot of things actually we did that time, and you can see the actual image of this. Okay, so with the help of this setup, we initially we tried some material. You can see the result initially that we obtained through the experiments. So you can see a lot of challenges were there. We were having the a lot of uh, problems with the setup, and these kind of challenge you cannot even figure out what kind of image is this or what kind of part geometry is this, right? So what happened slowly, we optimize the parameters, optimize the process. Then I will show you in the next coming slides the quality of the the printed objects. So we also developed a customized software module. As I told you that my setup was mounted on the CNC machine center, and as per the the standard procedure, generally we use it for the machining purpose. So there was no software available that can be used for the additive manufacturing on the CNC machine center. So that's why we developed this one, and here it was having the options like STL file import, control all the process parameters like layer thickness, feed rate, and in our case we use the screw based mechanism. So screw speed also one was the parameter. Then angle we could be able to the control, gap, number of cells. So these kind of parameters actually we embedded in this particular software module, and you can see the features, what kind of STL file or what kind of features actually were provided by this software. So you can see that this particular software was able to import and processing of the STL file, then slicing. Okay, do you know what is STL? Anyone can answer in the chat box what is STL file and why we use STL file in 3D printing. Sir, can you unmute them? Otherwise, it is one-way lecture.
Okay, sir.
Suppose if anybody want to answer, then or somebody want to interact with me,
Yeah,
then I can take their queries or also their answers.
in chat box, Dr. Shilpa Vinchurkar said standard triangular language.
Standard triangular language. Okay. So what? Okay.
Another participant said stilography language.
It's a stereolithography language. Okay. Sir, actually, stereolithography language, it was its previous name because
Stereolithography.
yes,
You
stereolithography.
wrote that
Actually, it was.
stereolithography language.
Oh, I understand, sir.
Hmm.
Sir, actually, what happened, because the first 3D printing process was stereolithography, right? So that is why people were calling it the STL. STL means stand for the stereolithography, right? So ST and L. So these three letters were taken from its name, but later on, STL file actually become the de facto standard, and all the people who are working in this area, they by default using this particular format. So that's why they have changed its name to the standard triangulation language or the standard tessellation language, right? So it is one of the format that is very popular, and widely used across the 3D printing community. Okay, so our software are also having the same feature. It was also having the provision to import and the process the STL file. We were able to slice the STL file, and we were also able to generate the toolpath that was compatible to CNC Machine Center. Right. So here I have shown this spanner STL file. You can see the number of triangles. Okay, they are visible clearly, and also this is the slice model, and this is the toolpath that we have generated to just fill out the layers. Okay, and here if you look at the toolpath, right, toolpath, here we have used different kind of programming like G00, G01, M04. So if you know the coding of CNC machining, then you can relate the meaning of these words, okay, or these codes, right? G00 for rapid movement, M04 is the anti-clock direction of the tool. So those codes actually we have incorporated in the software, and our software was generating the code that was compatible with the CNC machine center, right? So these were the feature, and here a few other images where we have shown the capability of that software. Okay, then we optimize the parameters, then we were able to make these kind of shapes. Still they are not that much improved, but still we were able to manage some of the profiles. Then later on the same setup actually were used was used for flexible part fabrication. So in this case study we used EVA material. EVA, I think EVA is very known word that is very popular. If you go to any shoe store, they will always say like we have used EVA sole in this particular shoes. Okay, EVA. So EVA is one of the very popular material that is generally used in the shoe industry, and it is very much flexible. But in my earlier slides or the initial slides, I talk about the flexible part printing through triple F. So when you deal with highly flexible materials in triple F, obviously part failures are there due to the low column strength. So a lot of difficulties are there. So we thought we should uh, explore this particular process for flexible part printing also. So this material was taken, and then also its extrudability was checked. So we were able to extrude it in the wire form. But our target is to direct part printing through EVA pellets, right? So here you can see the profiles that we printed using the EVA material. And this particular sample manually to flexibility. So then we did a lot of part preparation. I'm not going to visit. I'm just showing you. Here you can see the part mounting. Also, it was having the possibility elongated to the 100% deformation. Okay. So then we did that same study about the fabrication. Because now if you the articles will have the applications of strength, right? So we want to develop some material that should be flexible in nature, and also it should be electrical conductive in nature also. So I'm skipping these slides. Okay, I'm just directly showing the what we did actually. Okay, so initially just to develop a low cost solution, we took this graphite powder and EVA pellets, right, and we mixed them together, and then with this setup only we made the shapes, and we checked their the microstructure and their mechanical properties, rheological behavior. Okay, so based on this rheological behavior, we identified the process parameter that were required for part printing. So for the rheological behavior, we use this melt flow rate, melt flow index tester, right? And also we check the diameter of the extruded. So these parameters actually we use to parameters that can be used for printing, right? can see the electrical conductivity part, and the parts were printed successfully, and the flexibility also, right? And why it was happening? Because as per the calculation theory, what happened when we increase the material, okay, and we for some specified value, then this kind of things are made inside the matrix. We can see, okay, so that one is indicating the content material. So here we obtained, the improvement in the electrical conductivity. So we have reported these results in one of my research paper that was published in Essay Journal. So you can refer for more detail. So one thing we noted that although the electrical conductivity was improved, but there was significant drop in the tensile strength because we used graphite, right? So the size of graphite particles actually was very high. So if here I proposed, future scope of work. If we add the EVA or graphene or nano these particles, then obviously we can maintain the tensile strength as well as along with the electrical conductivity. So here we observed the significant drop in the tensile strength. We also observed the significant drop in the electrical at break, okay, after addition of the graphite in the EVA matrix. So here we have, some mentioned few of the evidence. Like here you can see this is the raster, right, deposited road, and this is the another road. So this gap can be seen clearly here. So due to this poor bonding, because viscosity was increased after the addition of this graphite in the EVA matrix, so that's why flowability was decreased. So as a result, we got this poor bonding between the roads. So one hole you will see here, second hole you will see here. So multiple holes are there, right? These are the holes. So obviously they are not properly bonded. So that is why these drops actually in the tensile strength and occasional break were observed. And similarly, in other images also, same thing we have shown through the SEM images, right? So this is quite similar study, so I am skipping it, right? This is also the manifold behavior of aluminum filled ABS polymer composite. So same is kind of study we conducted through the same setup. Yes, this one is interesting. This is another case study in which what we did, we try to develop a hybrid direct parade printing system. Hybrid means there was what was the idea? Because we were using the machining center for 3D printing. So we thought, can we do 3D printing and machining on the same setup or not? So I and one of my the student actually and my supervisors, we thought we should develop a hybrid direct parade printing and machining system. Okay, so on the same setup, what we did, we tried to do the machining just after 3D printing. So here you can see that here this is the setup, right, and you can see the machining tool, right, that is moving. So here the surface finish is very poor, but after the machining you can see the surface roughness or surface finish has been improved a lot, right? So the results we reported here in this case, right, both of the parts we can compare. Okay, so after 3D printing, the surface roughness was around 19.49 micron, okay, average roughness, and then after machining it was reduced to 2.068, right? This CAD/CAM lab we printed from the same setup, and then after we performed the machining process to improve its surface, okay, and in order to do the hybrid manufacturing or hybrid additive and subtractive manufacturing, we extended some of the features in the previously developed software. So you can see here that on the left side we have the options or some of the the parameters that are related to additive manufacturing. But on the right side we have the parameters related to or that is required for the machining of the printed objects, right? So cutter diameter, step over, and then here on the left side we have roll width, layer thickness, STL import, slicing, tool path, GM code, right? So these parameters actually we incorporated into the single software module. And after that we did that particular the case completed this case study, and then another case study in which we try to fabricate the large parts. Large part means bigger part or the parts having the large surface area using the same setup. Okay, so in this particular case study what we did, we developed a build platform and we try to we try to this platform. So you can see there, okay, but actually build platform in this case because we wanted to check for the parts because we know all parts are having have the process area. So distribution is not that much high, but in case distribution will be very uneven across profile. So that is why the part we should use this for the last part of this application. So you can see we try to make these kind of components, okay, and we were able to make them. So here we try to make a chair, but unfortunately due to the power failure, this part printing was stopped. Okay, but you can see the size, right, and curved surfaces. So even though our setup was able to handle these kind of surfaces or the size, bigger size without any issues. Okay, another case study that is also based on this particular printing setup. Here what we did, so this study actually we conducted in 2016 actually, 8 years back. So that time this Hilbert toolpath was not available in the softwares. So we thought we should explore the new toolpath patterns because most of the researchers were only or using the raster based pattern, right? So we identify some of the challenges with the raster based toolpath. So that is why we explored this Hilbert toolpath for the part fabrication using direct current printing. So here what we did, okay, what was the reason why look at the raster position. Due to this, damage gradient is developed across the so we can explore a toolpath pattern which is having the small raster in its nature. Okay, so that's why we try to make, or we try to develop a tool path based on this particular space filling curve. So you can see it is having very small rasters. Okay, so in this way our hypothesis was to maintain the temperature gradient. So from the same setup we did this, and we explored in the MATLAB. We made this tool path. Okay, then we exported this in the form of compatible code of CNC Machine Center, and we found the improvement in the tensile strength due to this reason. Right. Then another case study we also carried out in this area, that is the low cost solution for direct pellet printing. Low cost solution for direct pellet printing. So here what you know this winter now that time was happening. Okay. Now this we return from the market and then modify it, remove this extruder pad, and then we use uh, this process with the development. Okay. Extruder pad, and then we replace it with this option. You can see the actual image of the extruder pad. So here the model of the extruder pad, and this is the actual of the or the extruder. Then we mounted it on this. See the part. Okay. During initial experiments, we tried to develop the cuboid, cubes, simple, rectangular shape, and then the part with various features. So in this part, this is the benchmark part. So in this we have this inclined surface, we have the square hole, we have the cylinder, we have hollow cylinder, we have large size cylinder, we have this the hollow cuboid, and also this benchy is very popular part. If we when we purchase any 3D printer, we try to make this particular part using that particular printer. Okay, so we were able to make this kind of benchy. Okay, benchy or boat. So we were able to develop this kind of benchy through this develop setup. So although the results were very satisfactory during the preliminary experiments, but later on we could not extended this study due to some reasons, technical reasons. But this is the area where you can develop your own setup, or else you can purchase the extruder head that is also coming in the market nowadays. You have to only spend 30 to 40,000 rupees, and you will get the extruder from the market, and you can mount that extruder on your 3D printer by just you can replace the commercial extruder head. Okay, and you can mount that particular head on your printer, and you can do the printing pellets. Right? And apart from my case studies, I found some of the research paper based on this direct pellet printing. I have not updated this slide, but I have seen more paper research recently that has been carried out. Okay, so if you just directly type the direct pellet printing on the Google Scholar, you will be definitely you will be going to find the studies based on this, and you will be amazed by the results. Okay, so here in this particular case study, they use this they develop their own universal pellet extruder, and why they develop, just to use the waste material, direct waste printing of polylactic acid. Okay, so they use this to recycle the PLA material. So you can see their results. Okay, and another case study in which the pellet extruder for composite thermoplastic 3D printing was developed by a company. So here you can see that the extruder head has been mounted on the robotic arm, and you can see the size of the platform, right? Size of the platform. So it is. So with this, we can make the large size parts obviously at high speed. Because, some printers are in this size, 1 meter by 1 meter. But when we use them, printing is not able to manage various. Okay. With this, the large parts and you the large size parts uh, also because it is having 6 axes. So these are the areas we are also use. And let's see the size of okay. This is printed size. Okay. And here it is the polypropylene 30% short glass fibers. So they have used polypropylene in this, and also as a reinforced material they have used short glass fibers. And here you can see the complexity of the pattern, or the complex shapes can also be achieved this with this. Okay, so this is also possible. And I have also identified some of the manufacturers uh, where they are selling their product related to direct pellet printing. So first one is the Juggernaut 3D. So their model name is Tradesman Series P344. The size is around 915 by 1220 by 1220 mm, and it was developed in USA, right? So they are also selling their printer based on this particular technology. Then Titan robotic system. So model name is Atlas 1.0. Size you can see here. It is also USA based technology, right? And Daisy Design, it is the model name is Pulsar. And what they are doing, they are just manufacturing the compatible pellet extruder for most of the triple F printer. So if you're interested, as I told you that if you're interested to just use the pellet extruder for your application, you can, rather than purchasing the new machine, you can purchase pellet extruder by just tuning the parameters, or by just making the little changes in the existing triple F printer. You can make your own pellet, or you can make your own pellet extruder for the use. So this is Canada based company, and here IT3D group, it is two maker NX Pro. So it is also it is very small billet platform. It is having very small Spain based company. Direct 3D pellet extruder model name. Manufacturer compatible, again the same thing. Okay, it is based on Italy based company Cosine. So they are also here. The given is the size around 2 meter, right? 2 and 1.5 meter. So they are also selling their printer in the US. And in India, I have come across that today I was searching, like, anyone, is there anyone who is making this kind of product in India? So I have found that one of the company, that is the Garuda 3D, it is company, I think Chennai based company is there, Hyderabad or Chennai. So Garuda 3D, so they have started is working on this particular system, and soon they are going to launch their new pellet printing system in the market. So expected date was around in the mid of November 24. Now I think they actually were not able to, I think, the lost their expected. But in future, in months, I think they will do it. So it will be better in it also, right? So you can approach them if you are really interested in this area. Okay. So let's discuss the challenges, right? What challenges you are facing, or where you are work, or what areas you went up for such purpose. So even the first challenge is decision and resolution. So as compared to the other building systems, this particular uh, approach for this is not precise enough, right? resolution is very poor. So here you can work on the process parameters. So you can fine tune all the what should I say, all the parameters to just get the fine details or good precision in the parts. So this is, I think, one of the area that is having a lot of scope. Second, uniform melting is also challenging because due to screw extrusion can be challenging with the composites. So this is also, I think, challenging composite. You need to do a lot of work in this area. You need to explore the some models related to polymer composites. You have to look at the screw profiles, the speed of the screw. A lot of things are there. Swelling, because one of the very phenom- uh, major phenomena in the case of screw based mechanisms. So you need to look at them also. Post processing, as I told you, it is having low resolution and poor surface finish, and have shown in these cases, in all the cases. If you look at this surface, this it is having very poor surface finish. Why? Because we are depositing material at high flow rate, right? And using the bigger size of nozzle. So in the case of triple F, almost we use the nozzle size of 0.4 mm. But here our objective is to make the large parts in quick time. So we can go for the large size nozzle. Okay. So that is why you need to devise a mechanism to improve the surface finish. So obviously additional steps will be required. Then only we can remove the aesthetic look of the printed parts. So here you can also some make some mechanism so that you can achieve the good surface finish during the printing of the materials. Okay, so this is also one of the area that you can look, right? So with this, thank you so much for listening me or for your time. Thank you so much. Thank you everyone. If you have any query or if you have any doubt regarding this lecture, you are most welcome to ask. Thank you. It is all from my side.
Thank you. Thank
Thank
you
you,
so
Dr.
much, sir.
Narendra.
Yeah, we will take up questions. Participants, you can type in the chat box.
सर कोई क्वेरी नहीं, इसका मीनिंग एक ही है, तो कुछ समझ में नहीं आया, सब समझ में आ गया.
Hey, sir, it was a wonderful topic because it was an addition of knowledge to the new thought process. Direct pellet printing, I was not aware of that, and you have worked in your doctoral work also. So I used to hear from Dr. Abhay that when you were together
There is one
at
question,
IIT
question in the
Jabalpur,
chat box
yeah,
from
how
Kumar
can
B.
we make natural fiber composite in pellet printing by Kumar?
Your voice is not coming, Dr. Narendra. Yeah, you are muted. Mic is mute. Jaju sir, I think you can
No,
unmute.
he can unmute. He can unmute basically because he is the co-host and presenter. Narendra sir, you can unmute yourself. शायद वो फिर से ज्वाइन करेंगे, कुछ उनके नेटवर्क में इशू आ गया शायद. Yes, yes, yes. Might be he might join again. Ah,
Hello, sir.
hai, hai.
Okay, okay.
Sir, now your voice is audible. You can now speak.
Sir, please confirm whether I am audible or not.
Yes, yes, you are audible,
Okay,
sir.
thank you, sir. Sir, here
Yeah,
I can see few questions like one of the participant is asking like how can we make natural fiber composites in pellet
yeah,
printing? So
yes,
obviously, sir, you can you can means cut them into the small pieces and you can feed them along with the plastic pellets. So then I think master batch extrusion you need to do because I think after first extrusion you may not be able to achieve the homogeneity in the composite. So that can be achieved by just repeating the extrusion process. And the second question is the can we print biomaterials like ceramics and steel? Sir, obviously we can do, and you can find a lot of papers is for so far as if I talk about the steel can be printed, but you need to mix it with the polymer. Then you have to means first you need to print the green part. Then you have to go for the sintering. So a lot of some additional steps are required. Then you can means print the steel also. So you can easily find the indirect metal printing. Okay, you just type indirect metal printing through X2 extrusion. You will find the research papers and the answer of your question.
yeah. Another question from can we print biomaterials like ceramic and steel?
Yes, I have sir answered this query.
Yeah,
Both
yeah,
mhm.
yeah, yeah. And there is a request from one of the
Sir, sure.
participant
I will
for
share. I will share. No issue, sir. I don't
yes,
have
yes,
any issue. I will share. And all
right,
work is published. My all work is published in the journals. You can also follow my
yes, yes,
Scuba Scholar profile for more
yeah,
details.
yeah.
Okay.
Yes. So on behalf of you, we will share this PPT to the participants.
No issue,
Right.
sir. No issue, sir.
Yes.
I
Yes.
will provide, sir. No issue, sir.
Yeah.
Mhm.
Because already we will be collecting the PPTs from all
No
the
issue, sir. No
resource
issue.
persons
Sir,
because
I'm
we
happy,
have to
very happy
submit
to
it to
share with them.
AICT. Yes. Yes. We will share with
If
the
sir if they
participants.
they come up with their new idea based on this systems, then I will
Right.
be very happy if they do something related to this. If I
Definitely. Definitely. Yes,
uh-huh.
sir, ourselves want to get connected on this pellet printing, and basically we want to means have similar kind of work to be executed in our college also.
Sure,
Otherwise,
sir,
sir, we will
sure.
just get the guidance from sir, and we will give one or the two projects to MTech students also, sir. So that
Sure. I'm very
yeah,
happy.
yeah,
I will be happy, sir.
Again,
right.
one question from Maharajan also. How
Sir,
can
how
we
can we
avoid?
avoid defects? I can read, sir. How can we avoid defects like pores during 3D printing? Sir, in 3D printing, you cannot avoid pores. Always the structure will be porous due to the the layer because we are adding material in the form of layers. So on the large scale, sorry, on the microscope scale, always there will be porosity. You cannot completely you cannot remove the porosity completely from the printed parts. But obviously there are some methods. You can reduce the layer thickness. You can play with the parameters so that you can minimize it. You can minimize the porosity, but you cannot remove or you cannot avoid the porosity from the printed parts. So this is, I think, the answer of your question, sir.
Some comments are also there. Direct palette printing is new concept and case studies explain show that there is a lot of scope for research work.
So a lot
Screw
of
type.
scope is there, but currently I have stopped, working in this area. But still, I am doing some projects on the direct ink writing. We have developed some new setups, and I am also working on the robotic arm-based 3D printing. And so I am working on the projects. Some projects we are doing with the ISRO, and some projects are funded by the government of India from the SCRB. So if you're interested, then you can contact me. What kind of projects I'm doing right now? Okay, or you can follow means my profile for more details. Okay. If somebody is interested, then you can contact me directly. I will give my number, or you can take my number from Avesar. Okay, or my email ID is with him, so you can contact him, or you can search on Google, right? Or I can just type 79873.
Yeah.
This is my number, and this is my email ID. Okay, sir.
Yeah.
Is there anything, sir? अच्छा प्रोग्राम चल रहा है सर आपका, because today
Yeah.
Piyush
Thank
he
you.
he said he has delivered talk
आप
today.
आप सब लोगों का हमको यानी साथ मिल गया तो वो प्रोग्राम अच्छा होना ही है
नहीं,
सर।
sure. Always
You
there,
are
sir.
the expert in this domain area. तो experts अगर उस domain के proper मिल जाए तो
जी.
बढ़िया हो जाता है सर। ये main है because learning has to be there. That is more important because
Thank you.
in this even odd time also faculties and participants have joined and they are means paying attention to the talk.
And
That
asking
itself
so many
shows the
questions.
yes that itself shows the
Actually, sir,
means,
first talk I delivered in Raisoni. My
yeah.
career first talk. My career first talk I delivered in Raisoni, sir.
Yes. That was in I think so AICTE STTP.
Yes. At that
Yes.
time, I think Dr. Vishal Francis and Dr.
Right. Vishal Francis was there, and that program also I got the grant from AICTE for conducting 2 weeks STTP program.
I remember,
Yes.
sir. I remember, yes, sir.
Physical में कौन था
अभी
आपने?
हाँ
तो 2018 या 19
Dr.
की बात
Raghavendra
है.
was there. Dr. Raghavendra was there, sir, at that time.
yes हाँ Raghavendra was also there.
Upadhyay, yes.
Yes.
उपाध्याय.
या वो पूरे यानी क्योंकि उन लोगों के यानी उन लोगों का काफी हेल्प रहा उसमें बहुत ज्यादा. अभी यानी अभी तो पूरा इसमें यानी कंटिन्यूअस यानी फॉलो अभय का ही रहता है पूरा.
That is good, sir. Abhay sir is all
And
Great that. By this way
he
only
keeps
we
in touch
can
with also.
connect each other. Otherwise, you know, Jalandhar
Yes,
is
sir. Very far away, sir.
ऐसा है मुझे कुछ भी ऐसे लगा कि भाई कि मुझे यानी चाहिए कुछ रिसोर्स पर्सन तो बस इसको बोल दिया. अभय के पास पूरी लंबी लिस्ट रहती है
Sir,
पूरी.
Piyush is doing PhD under my guidance, sir. Yesterday he was with me here, Jalandhar.
Okay. So his session was there from 6 p.m.
Yes.
Basically.
He informed me just
Yes.
before my lecture.
करेक्ट. तो एकदम क्या आप लोग हार्डकोर रिसर्चर्स है सर ये फील्ड के. तो हमको कैसे कि बहुत अच्छा लगता है बेसिकली.
Sir, thank you so much, sir.
हाँ. Nivedita, feedback link will be shared through the ATAL portal only. So there is no right now the feedback link, and don't worry about that. And even the attendance will be marked in the AICTE portal from the means login. When you do the login, we will get the basically your email ID and your timing of attendance, and that's why you don't worry about the attendance and feedback. And at the end we will be having the exam on the last day, so don't worry about it. Thank you.
Okay, sir. Thank you.
Thank you, sir. Over to Nirvan, sir.
Yes, sir. Thank you, Dr. Narendra Kumar, sir, for that insightful and thought-provoking session. It is truly inspiring to witness how direct pallet printing is paving the way for smarter, more efficient manufacturing solution. On the behalf of the organizing committee and all the participants, I sincerely thank Dr. Narendra Kumar, sir, for his invaluable contribution to this program. Your expertise and insight have truly enriched our understanding of this transformative technology. Thank you, sir.
Okay, sir. Thank you so much, sir.
Yeah.
For your
Thank you,
time
thank you,
and
sir.
invitation.
Thank you,
Thank
Mileke,
you.
sir.
Namaskar.
Thank you. Good night, sir.
Namaskar.
There is an instruction to all the participants. Please check your attendance in AICTE portal. I have marked all the attendance of day 1 into the AICTE portal. Day 2 attendance will be marked by tomorrow before 12 noon. If anyone have the query or any type of the problem, then they can directly WhatsApp to my personal number. Thank you everyone for your attention. We will be joining to the next session on tomorrow. Stay tuned.
Thank you.
Thank you.
Thank you.